Jo. Moin. Servus. Habe Dere. Hey everyone. Hi, I'm Mario. And I'm glad to be here today. Who am I? So I am a customer delivery architect at Kubernetes. I'm also the comms tech lead for the Kubernetes project, and I'm part of the last week's in Kubernetes development newsletter, and I'm also a GDE and an ARM ambassador. So most of the stuff that I do is Kubernetes work. Yay! Happy birthday, by the way. Kubernetes is, we have a multi-cloud, multi-cluster live platform for managing Kubernetes clusters, running Kubernetes inside of Kubernetes, and we also do some trainings and consulting. But we are here for the important thing, to talk about the old world. How great is security in the past, and how we all love talking to our security teams, because they are such nice people. So we basically, the old world, the old security world, we can describe in three different parts. So we have our parametric-centric defenses, which is basically we build a wall around our castle. We have our reactive process, so if something goes south, then we do something, maybe not. And we also have a silo approach, so I'm the security department, I'm in the God layer above, and I can basically say, you can do this, and you can do, but you can't do this, and I don't talk to my developer teams, and I don't talk to our ops people, and I just imply topics to our security. So let's start with parameter security. Parameter security, as most of you know, is basically, and what a lot of companies did in the past is we built a castle around our IT, which is known as the great firewall that we rely on. We rely on the outside, that attacks come from the outside. The problem is this does not happen anymore. And when I say anymore, I mean this was already not happening 10 years ago or 15 years ago, because what is the most or the easiest attack vendor into a company? Any idea? Yeah, exactly, because internally and or the human. So one thing I bet all of you know, the CIA was hacked because someone left a USB stick on the parking lot, and someone took up the USB stick. And what do you do with a USB stick that you find on a parking lot? Exactly, you plug it into your working computer and see what's on the USB stick. So that's basically that's why a parameter defense don't work anymore, right? So we need to train our people. I mean, and we all know the security trainings that we do, and where we all love it, and we all need to do it every year. We basically we need to protect our users. That they don't are the target, and that they don't fall for traps to go and leak critical data. Because a hacker is not sitting at a computer. A hacker is sitting at a computer, but a hacker is basically the vector is like, I send you an email, I do social engineering, and so on and so forth. So what we basically need to do is we need to have a multi-layer security concept for all of this. But as we already pointed out, the main problem that we have is our human layer. And the human layer is not always so obvious. So for example, who of you does meetups in their company? Okay, and most of the time you order pizza, right? So basically, what you do is you let the pizza service delivery guy inside of your company at 9 p.m., 10 p.m., because you trust the person that they are only delivering pizza, right? And they don't see, they go through your offices, the people go through your offices, and no one will ever wander off. So this is also human engineering or social engineering. So this is already an attack vector to your company, to your thing, because all of you trust, like, I have this buzzer to get into my company, but people let folks into their service providers just because of this. So it doesn't matter anymore that we have those securities, because I can go around those securities like we saw in the picture before. So what we need to do is we need to build a resilient layer step by step on every layer that we have until we have in the most secret part our mission critical assets. And I know companies that have their SSL certificates locked up in a safe because of this. And you need 2 people to access those to renew an SSL certificate. So this brings us to our manual and reactive process. So who of you don't know what a CVE is? That's good. Last time I asked this question, there were way more hands up. So we have currently 240,830 CVEs. I looked this up like 20 minutes before I had the talk. In April, when I had this similar talk, it was 233,000. So a CVE, as we all know, is a vulnerability in software. And those are growing tremendously fast. And those need to be fixed fast. So when we have, these were the amount of vulnerabilities that we had in 2023. It was 5% more than in 2022, and it was 24% more than in the year before. And when we look at the statistics from 2000 to now, this is not manual fixable in your system, because one of those CVEs will affect you. And they are tremendously trying. And if I'm in a reactive phase for this, and if I'm just only reacting to CVEs, I will run into the problem that I can't keep up with this number. That's just too much to fix. And the funny thing is, this number is even being inflated because there was a change this year. It was in May, because kernel.org is now an official CVE numbering authority, which means that kernel.org can now create CVEs. And the problem with this is that they are back creating CVEs, which inflates the number, which brings us to another problem, that there are CVEs that are being reported that are already being closed because they are fixed, because they were a bug in the kernel and not necessarily a CVE. But how can you decide if the CVE affects me or if the CVE don't affect me? And so we need an automation or an automated process and a multi-layer defense to prevent us from running into those CVE issues and to basically say like, hey, I need an automated way to fix my shit. And we have the problem that teams don't talk to each other. Who has a security team in their company? Okay, and who is talking to them weekly? That's not so much. I guess all of you are ops, right? Who is a dev? Who is a ops? Okay, it's 50. How often are you talking to the either or the other? So if you're dev, how often do you talk to ops, and the other way around? Once a week? Daily? A month? Once in a month? Okay, at least you talk to them. So basically, to fix this in the past, we created something that helped us. We created, there was container work created because I have my containers, and I can now ship my developer machine, as we all know, because shipping my machine is good. And the problem is that we still have the upper problem. We still have the horrible machine. The horrible application that is just an inside of a container, and then we just ship the container. Great, we solved the security problem, everything is good, so nothing can go wrong. Why do we do this? I mean, this is really old, right? This is past us, and we are way away from how we treat our infrastructure. Who of you named their database server or gave it a specific name? Like, I did this, 2006. There was like I named them with anything from the Nordic mythology. The problem is that if something goes wrong, then it can't recover. So we move to Kettle, and we get to this Kettle approach in a bit again, because who of you can throw away their Kubernetes cluster and just have everything deployed to a new Kubernetes cluster in an automated way? Oh, it's 6 people. That's good. And how fast can you do this? 1 hour? 2 hours? Depends on Azure. Depends on Azure is a great answer. Okay. To give an example, also to get now into the new world, because we don't want to ruminate on the past. So we basically ports. Everyone used ports. In the old way, I needed to talk to a security department because we wanted to open the port range 30,000 to 32,200 something for the Kubernetes ports. And they said, like, it's too many ports. You can't open them because it's a security risk if you open so many ports. So what we did is we limited it to 200 ports, and then they deployed 250 apps, and they are wondering why 50 of the apps are not reachable anymore. Surprise. So basically, we have the problem in the old world that everything have a clear name. Everything is it's predefined. We have a network that says like, hey, this application can talk to this port can talk to this, and the good thing is it's easy to manage because I have a large Excel list that tells me who can talk to whom. The problem is, in a cloud-native way, we have ephemeral ports. Port 80 doesn't mean port 80 anymore, because a port is just a point where I connect. I have a ton of microservices that talk to each other. So the approach that we need to go is basically, we need to go into encrypt everything, don't trust anyone, and only allow traffic. So we need to go into a way that we have like an observability that I don't see anything going left and right, and I need to go ahead and say like, hey, only application A can talk to application B. Everything else is blocked because everything else is a security risk. And I don't care about a port, because a port doesn't matter anymore. So what we need to do is we need to do microsegmentation on a networking level. We need behavior analysis, because this is the only thing that tells you if something goes south inside of your cluster. Because if you have malicious software somewhere deployed because you don't know it, the only thing what you can say or how you can see it is basically, hey, I need to watch what is happening inside of my cluster and that is not behaving in a normal way. We can go ahead, and we have great things with API gateway to have central points where identity checks come in. We have security mechanisms in it. We can do microsegmentation because we can basically slice smaller networks that we only have small networks that talk to each other. And everything should have an identity management. In the past, it's still not portless, so we still have ports, but ports are not the main reason for having the identification of what is going on there. This is old. This is why we did DevOps. So now Dev and Ops are talking to each other on a regular basis, because this is not a job description. Whoever basically writes in a job description, we look for a DevOps engineer, didn't understand DevOps. This is a team. This is multiple people that do multiple stuff. And everything needs to be redoable and automatable in any kind of way. And clusters are becoming Kettle. And this was already set at 2022. So you should not treat a cluster as, hey, a cluster is the one and only truth in my system. You should treat a cluster the same way how you treat it like containers and how you treat it like your services, your microservices. They can go away, they can die, and I don't need to rely on them because they need to be self-healing in the end. So what we need to do is we need automation, so we need to automate all of our infrastructure. We need to do an immutability, which means everything is infrastructure as code, everything is only a pull request, there's no human interaction with your environment whatsoever, because if you do an interaction with your server, yeah, I can go in my shell and change something in my in the environment, but who remembers this in a year, what was changed in the manual process? No one will be. And we need to observe it every time. And observation, I mean like, what are anti-patterns that emerge in my system? Because if everything behaves the same way all of the time, that's fine. What we are looking for is what is not, what is strange in our system. So what we want to do is a shift left, and I know this is a rather debatable topic because this adds a lot of more to the plate of our developers, but we need tools for this. So who is familiar with SAST and DAST? All right. Then I don't need to, yeah, of course. So SAST is structural testing that basically identifies and generates reports based on the code base. So this is already a security check for the code base. What means this? I take Go as an example. So we are reliant on Go packages. And there's vulnerabilities in Go packages. And what SAST basically helps us is, with SAST, we can determine if there is a CVE in an underlying package to figure out, okay, we need to update our service because there was a CVE in a package that we use in our application. And SAST you can have in your IDEs, there are paid tools, there are some open source tools, depending on the language that you use. But this is basically something that helps us to check our code if it is all right. Dust on the other side is black box testing. It's end-to-end testing. It's testing the whole stack and seeing what goes wrong and what behaves in a strange way. So this is basically then the thing that comes after, and this is also something that a person can do that don't necessarily understand code. They just can go and hit vulnerabilities. Container scans, because who uses Docker images from Docker Hub and is relying on them? Probably a lot of people. Who of them is regularly checking checking them for vulnerabilities? Could be more, right? Who is doing compliance scans? This is getting even more cool in the next time. Okay. Also a few people, and the good thing is I see the same hands raised, so basically everyone else needs to go into this direction as well, because we have such beautiful things as GDPR in Germany and in Europe as a whole. So we need to rely on that our code is compliant and that things doing this. And I had an interesting discussion. Compliance will get even more interesting when it comes to LLMs, because who can tell you if your LLM behaves in a compliant way and is not spitting out data that it shouldn't. So compliance scans is not only for security, but also for compliance, and dependency scans, as already mentioned. So what we basically need is a zero trust architecture. This means we need to verify everything in an automated way. We need least privilege access everywhere so that no one gets into our system and that the system itself, the applications don't get anywhere. And we need to basically micro-cement everything that if I have a problem, so if I have something that explodes because someone used a malicious container, or best newest thing now is deployed a malicious LLM inside of your cluster, because they just took it from Hugging Face. By the way, half of the images of Hugging Face are infested with malicious code. So have fun, based on a JFrog study. So we are basically Docker Hub all over again. So we need to basically reduce also the blast radius, which means that we need to, in our cluster, we need to put in policies that applications cannot get out. So we have identity as a new parameter. And in Kubernetes, it's cool because we have role-based access control, we have identity-centric segmentation, and I can basically also give service accounts that they only can talk to each other. Getting over to tooling, what can we do for tools? Well, how can we move forward with tools? So we have container scanning. I only talk about open source tools, so please feel free. So we have Claire, we have Trivy, we have Gripe, that is basically utilizing, and I always forgot it, Sift, to generate also a software bill of material. They all work together with, or most of them are all working together with Haber, so you can have it in your CI/CD pipeline, you can have it in your image registry, that are scanning for vulnerabilities in OS packages. And I mean, the best or the most interesting part is do this on a regular basis. Even we all know if you have microservices, there are some microservices that you will never touch or that you will rarely touch in a year. And the problem is they are the first ones that will go down with a security impact. So this is basically what you need to double check is, hey, is my application, because my CI/CD pipeline checks it when I deploy it, but who checks this on runtime? And then we basically go to the Kubernetes service where this is then happening. So we need also runtime tools that are checking those images for what is happening there. And there are a couple of tools. So we have Kubebench that is basically checking against the CRS Kubernetes benchmark. Fun fact, most of you won't fulfill a sys benchmark because sys itself won't fulfill a vanilla Kubernetes cluster benchmark. We have kubehunter that is basically doing attacks on your cluster to find exploits and vulnerabilities. And of course we have AI. KDSGPT. KDSGPT is an open source tool, it's a sandbox project in the CNCF, and it basically scans your cluster for events. This is done without AI because you don't need to do this, and then is sending it to any AI backend that you want. This can also be a local AI backend, local LLM or something like this, and gives you potential fixes. And last but not least, Popeye. Popeye is linting your cluster, is detecting misconfigurations and trying to help you how you can improve on those topics. Of course, the last thing, but I don't want to go deeper into this because there are way better people that can talk more about observability and how to set it up, is basically anything that you always need to have your cluster up and running in a permanent checking environment that basically says you, hey, what is happening, what is going on, and what is strange. That's the most important thing. You always go for what is strange. So we come now to the evolved status, which is DevSecOps. And DevSecOps basically is also not a role, it's a team again. So we are talking, everyone is talking together because everything is combined. And basically a software development team should not be like, I have my developers, I have my security, and I have my ops. No, I should build frames around a team where I have all of this competence, because a security engineer can help the developer early in the stage and give feedback in the development stage to see in which direction I should go. And the ops people can already say like, hey, how do you want to structure? What are your requirements for the environment? So the main thing that we are looking for is have all of the parties together, let them talk to each other, share responsibilities for security. That's the most important thing. And we want to have it as a process, not as a, yeah, and we got this paper from our security department that tells us what to do. And from our side, I know the security departments are usually a little bit conservative. We also need to teach them, because they are still in their old world, and it's hard for them to adapt to those new changes and to those new paradigms. So we basically have like these three principles, but in the end, it's like they build on top of each other. So they are a combination of all of those small base stones, and in the end, we basically have our whole infrastructure. And in the end, we will have Triceratops, hopefully. Fun fact, DevStack MLOps is probably the next thing that is going to happen, and I'm not looking forward to it. All right, that's it. Thanks, everyone. Thanks for being here, and enjoy the rest of the day. Any questions? If not, I think one more session and then, there's one.
Thank you so much. That was a great presentation. I have a quick question. Where can we get access to these slides, please?
The slides have been uploaded to a Google Drive of the conference, and they will share it afterwards. Then they are already shared.
I think they will communicate.
Yeah, but I also will put them on Twitter.
Okay, great. Thank you so much.
All right. Thanks, everyone.